All right, today we're going to have a quick review on solving 1 and 2 step equations so that we can use this skill to identify missing values within angle types. So if we take a look, these are examples on the screen here of 1-step equations, meaning that we have one operation acting on the variable. So even if I just kind of quickly highlight the expression with the variable in each of them, again, you see one operation and one number acting on the variable. And how we solve one-step equations is that we use inverse operations to get that variable by itself. So if we see addition, we're going to use subtraction. If we see subtraction, we're going to use addition. And multiplication and division are inverses of each other. So taking a look at this first example, we have x plus 14 equals 20. Again, the highlighted area here, that's the side you're kind of focusing on first. And we see the addition operation. So to undo it, we're going to subtract 14. And you do it from both sides of your equation, meaning both sides of, if I drew myself a line down the middle, I'm going to subtract it from the left-hand side and from the right-hand side. Now again, the reason why we use inverses is because when we perform the operation on the side of the variable, it eliminates itself. And we're left with just our x value. Equals is still along that line, and then performing the operation on the right, 20 minus 14 is the answer of 6. Moving on to number 2 here, x minus 20 equals 80. Again, that highlighted portion of my equation shows my variable and a subtraction of 20. So the opposite operation would be to add 20. And again, I'm looking at both sides of the equation, performing that operations. We're going to add 120 to both sides. X is then left because, again, inverses cancel out that term. And we're left with x equals 80 plus 120 is 200. All right, here's an example of multiplication. We have 3 times n. Remember, when a number is buddied up directly with a variable, that indicates the operation of multiplication. You won't see ever the x being used to show multiplication because, again, in algebra, it can be confused with the variable. So we oftentimes have it just buddied up against each other or with parentheses. So the opposite of multiplication is division. Again, I would perform this operation, the inverse operation, on both sides of my line here. So we're going to divide by 3 on both sides. Now again, inverses cancel, and we're left with just the variable, which is our goal. And then 12 divided by 3 here on the other side is the answer of 4. Okay, last example here. This is representing division. My fractional bar here is the operation of division. So we have k divided by 2 is equal to 16. The opposite of division is multiplying. And again, we would perform that on both sides. So times 2, and again, shy away from using that x to indicate multiplication because that's easily confused with the variable x. So again, we can use the dot, we can use parentheses, however you like, but just stay away from the x. Inverses cancel. 2 divided by 2 is 1, right, which is still 1k is k. So again, inverses cancel it. And then here on the left, or I'm sorry, on the right-hand side, 16 times 2 is 32. All right, my apologies. I probably should have started with this, but I totally forgot to mention it. For credit today, I would like for you to write down these equations and how we solve them in your geometry paper packet. So you can find these problems on page 13 of your packet. You can go ahead and pause the video here, go grab your packet if you don't have it handy, and copy down these 4 problems. When you're ready, go ahead and resume the video. We're going to go on to 2-step equations. All right, so when you're solving 2-step equations, you basically have, again, 2 operations acting on your variable. So when I look in my 2 examples here down below, I look at this first example, we have 3 times x plus 5. So you see multiplication and you see addition. On the right here, we see multiplication and subtraction, 5n minus 11. So you're just doing the inverse operation twice because, again, you've got 2 different operations acting on the variable. So if you remember from before, we always work with moving or using the inverses for the addition subtraction operation first, and then we deal with the multiplication and division operations with the variable. So this first example here on the left, we have 3x plus 5 equals negative 16. Again, we're going to be looking at removing the addition or subtraction first. So we have a plus 5 there. That's where we'd want to start. So again, using inverse operations, the opposite of addition is subtraction, and we're going to do that to both sides of our equation. Now again, inverses cancel, and we're left with this 3x on the left. So we're just going to go ahead and bring it down. And then it's equal to negative 16 minus 5. So when we perform that operation, we end up with negative 21. Then from there, we're going to take a look at undoing the multiplication or division that we see in the problem. So in this case, 3x is multiplication. So our opposite would be to use division. So I'm going to go ahead and divide on both sides. We're going to divide by 3. So again, the purpose of inverses or opposite operations is to eliminate them from the variable so that we're left with just our variable, in this case, x, all by itself. Performing this operation here on the right-hand side, we have negative 21 divided by 3. That's going to give you the answer of negative 7. All right, so looking at the second example over here, we have 5n minus 11 equals 24. So again, my operations that you see are multiplication and subtraction, and you would want to remove the subtraction portion first. We're going to undo that part first. So the opposite of subtraction is addition. So we're going to add 11 to both sides. Again, inverses cancel. So we're going to go ahead and bring down our 5n. And 24 plus 11 is 35. Then from there, this is the operation of multiplication in here. And that is our second step. So we want to undo the multiplication, and we do that through division. So we're going to divide each side by 5, remembering that we do same thing on both sides of our line. 5 divided by 5 is 1, or it kind of just completely cancels. We're left with just the variable, which is our goal, and we have n equals 7. So again, guys, these problems can be found in your page, on page 13 in your work packet. Please copy those down and submit a picture for points.